Hey listeners, welcome to Episode 2 of the Lab Report, Cracking the Periodic Code. With me today, I have Carolyn Bertozzi, an American chemist and Nobel laureate. Thanks for being here today, Carolyn.
Thank you for having me on.
To get started, can you explain to our listeners what atoms are and how they affect their charges?
Sure. An atom is the smallest unit of an element that still keeps the properties of that element. Each atom has a central nucleus containing protons, which have a positive charge, and neutrons, which have no charge. Surrounding that nucleus are electrons, which carry a negative charge. In a neutral atom, the number of protons and electrons is the same, so the charges balance out. But atoms can gain or lose electrons. When that happens, they become charged particles called ions. If an atom loses electrons, it becomes positively charged, and if it gains electrons, it becomes negatively charged.
Very interesting. Could these charges also help us organize the periodic table? And if so, how else do we group all 118 elements?
That's a great question. The periodic table is actually organized primarily by the number of protons in an atom's nucleus, which we call the atomic number. As you move across the table, each element has one more proton than the one before it. But this table isn't just a list. It's arranged so that the elements with similar chemical behaviors line up in the same columns, which we call groups. These similarities often come from having the same number of outer or valence electrons.
You mentioned the chemical behaviors. How might this play into how different elements react with each other?
Chemical behavior really comes down to how atoms use their valence electrons. Atoms tend to react in ways that help them reach a more stable electron arrangement. Elements with just one or two valence electrons often lose them easily, which is why many metals are quite reactive. On the other hand, elements that are close to having full outer shells tend to gain or share electrons when they react. Because elements in the same column of the periodic table have the same number of valence electrons, they often react in similar ways.
Building on that, how might the outer or valence electrons be depicted in Bohr-Rutherford diagrams?
That's where Bohr-Rutherford diagrams can be really helpful. They're a simple way of drawing an atom so we can visualize where its electrons are located. In the center, you draw the nucleus with the protons and neutrons. Around that, you draw rings that represent energy levels or shells where electrons exist. The electrons on the outermost ring are the valence electrons, and those are the ones most involved in chemical reactions.
Thank you for joining us today, Carolyn, on Episode 2 of the Lab Report, Cracking the Periodic Code.